understand why AI models fail at complex tasks, look at the context window. This is the model's live working memory, the specific tokens the AI is actively reading at the exact moment of reasoning. By 2026, the scale of this window reached a massive 2 million tokens. That is enough capacity to ingest 1,500 pages, an entire codebase, or 30 novels in a single prompt. This illustrates the problem. On a clean board, a single connection is easy to spot, but flood the space with 1,000 points of interest, and that path disappears. The system weighs every scrap of data until the core signal is lost. Builders often treat this space like a gas tank, assuming it should be filled to the brim with edge cases and conversation history. The instinct is to provide as much context as possible, just in case it's needed. This instinct to maximize volume creates a paradox. Instead of getting a more complete view of the problem, the model's performance begins to drift, often failing on the very facts that were just added to the prompt. We can measure this drift by looking at how a model handles information based on location. The foundational Lost in the Middle study proved that accuracy is dictated by where a token sits within the prompt. This pattern was not solved by the massive models of 2026. It remains a dominant failure mode across the deepest frontier models available today. This chart maps accuracy against position. A model scores highest at the edges, but faces a 30% drop when that fact is buried in the middle. The loss is triggered only by moving the token into the center of the prompt. Larger context windows provided more room for data, but they also created a massive, unreadable middle ground where critical information is lost. A Chroma study of 18 frontier models found output quality degrade sharply as the input grows. Several models held strong accuracy at first, then fell off a cliff once the input crossed a specific threshold. Researchers found a strange tell. When they shuffled a document into incoherent nonsense, the models actually got better at retrieval. Clear, logical structure actively hurt the AI's performance. This is context rot. It is an architectural property of transformer attention, meaning it is not a capability gap that more training data will eventually fix. Context rot has 3 mechanisms. First, attention dilution. At 100,000 tokens, a model weighs 10 billion relationships, leaving each token a thinner slice of the attention budget. Finally, distractor pull. Irrelevant but similar information actively pulls the model toward the wrong answer. Feeding an AI a logically structured, information-rich document gives it more plausible distractors, which can weaponize the attention mechanism against itself. The needle-in-a-haystack benchmark masked this weakness for years. By hiding one fact in a pile of blank filler text, it allowed models to use keyword shortcuts, making the test artificially easy. Adobe's NoLiMa benchmark completely removed those shortcuts. It strips away shared words between the question and the source, forcing the model to infer a latent link to get the answer. When forced to infer without shortcuts, accuracy plummeted. GPT-4o dropped nearly 20 points at the 32,000 token mark. Llama 405B fell below half, and Command R+ collapsed to just 21%. These failures hit the everyday prompt too. Overstuffing a toolset or conversational history ruins the output of even the sharpest instructions. The massive token capacity on the marketing box is often misleading. The effective length where a model can reliably reason is drastically shorter than the advertised limit. These findings have led to a new discipline, context engineering. The goal is to find the smallest possible set of high-signal tokens to maximize the likelihood of a correct answer. The first tactic is re-ranking. Instead of passing every retrieved document to the model, a re-ranker scores each piece of evidence against the question and keeps only the top results. The second tactic is positioning. To beat the lost in the middle effect, builders place the most relevant evidence strictly at the beginning and the end of the prompt. The final tactic is compression. Tools like Google's Agent Development Kit automatically summarize and prune history, cutting token loads by 60 to 80% without losing decision quality. Pruning the input ensures the model's attention is reserved for the facts that matter. Curation serves the accuracy of the final response, regardless of the token budget. The defining skill for builders today is no longer maximizing the context window. It is acting as a ruthless curator of what the model is ever allowed to see.